Hey, it's me, Miss B, and in this video, we are actually looking at two lessons today. So this is the Unit 2, Lesson 6 and Lesson 7 cumulative practice problems. So let's get started. I'm going to try to go through them pretty quickly since there are two. It might be a little long, but I'll try to not be as long-winded this time. For our first question here, they're asking us what information is needed to show that triangle DBC is isosceles. And so DBC is this triangle right here. And to show that's isosceles, that means we want to show that DB and BC, so this line and this line, are congruent. So that's our goal. So let's first look at option A. If they said line AB is an angle bisector of DAC, they're saying this one splits this angle in half. And that is actually going to be enough, because if these two angles are the same, that means that I have a shared side between those two non-colored in triangles to prove them congruent. And then if those triangles are congruent, we can then say these sides are the same by CP/CTC. So A is enough. Part B, or option B, says BAD congruent to ABC. So BAD congruent to ABC. So that's saying this angle and this angle here. And that is not enough because those would not give us things that correspond. Even with the shared side being congruent, it's not going to be enough. So that one doesn't work. And we have angle BDC congruent to BCD. So BDC congruent to BCD, that's actually just telling us about these two little angles in our blue triangle here. And that is enough because of the isosceles triangle theorem. It works both directions. In an isosceles triangle, the base angles are congruent. So yes, that would be absolutely enough to tell us that it is isosceles. Option D says angle ABD is congruent to angle ABC. So ABD congruent to ABC. And that would give us, so that's saying this angle and this one. And then we would have a side. That's actually SSA and not like SAS. So we can't use it because SSA is not enough to prove that something is congruent. So not going to use that one. And then if they just said that triangle DAB is congruent to CAB, we have to make sure those are in the right order. DAB and CAB, those are in the right order. That would mean these would be congruent. So this one would work also. So your correct answers for this one are A, C, and E. Now in this next question, question 2, Tyler has written an incorrect proof to show quadrilateral ABCD is a parallelogram. So he knows a couple of things. He knows segments AB and DC are congruent. So I'm going to mark that first. AB and DC, he knows those are congruent. And he also knows that angles ABC, so ABC is this angle right here at B. And then ADC, that's this angle right here at D. So he knows those things. And I'm going to mark what he is saying in red, and then we can, as we go, you'll actually see why he's incorrect. So he says AC is congruent to itself, and I agree that any segment will be congruent to itself, so we'll mark that. So then he says, so triangle ABC is congruent to ADC by side angle side. And if we look here, let's check, but I don't think we have side angle side. I have a side, and then an angle. So side, side, angle is not a congruence. Everything else in his proof is actually mathematically sound if you want to read through it, but this part is not. So we can say side, side, angle is what he has, not SAS. And then we can say SSA is not enough to show triangle congruence. Okay. Now with question 3, we have two triangles here that are isosceles. The first one they're talking about is just the entire outer edge of this triangle, and then the little triangle inside is also isosceles. But they haven't told us anything about these two on the sides. So they just want us to find different measurements, or a different measurement based on measurements that they're going to give us. So this is going to involve a little bit of some calculations, but it's actually not that bad. All we're going to do is use triangle addition properties, meaning that triangles add up to 180, or the fact that a circle has 360 degrees. So I'm going to label first what they have on the inside here. They said BAC has a measure of 18 degrees, so I'm just going to write that in here real small. And they said BDC has 48. So BDC, that is this angle down at the bottom, that's 48. They want us to find the measure of angle ABD. So ABD is right here. I'm going to mark this one in red. We want to know what that is equal to. So the first thing I see is that this is actually 360 degrees all the way around. And this side should also be the same based on side congruence. If we want to say, you know, like this side is congruent to itself, then our triangles on the left and on the right should be congruent to each other. But it's missing a third chunk, and we don't know if it's split into 3 equal pieces. That is this part down here, and we can find that one pretty easily with our isosceles triangle DBC. So because it's isosceles, we know the base angles are going to be congruent. So these are both 48, which means added up, those are going to be 96. So we can take 180 and subtract the 96, or you can think of this as subtracting 48 and then subtracting 48 again. That is going to leave you with 84. So this angle right here is 84. We're going to do one more piece of arithmetic, which is to take 360. We're going to subtract 84. And then that whole thing we are going to divide by 2. So if we take 360 and subtract 84, we get 276. And 276 divided by 2 gives us 138. So our answer here is going to be 138 degrees. So I'll write it a little bigger, and I will say measure of angle ABD is 138 degrees. And we're skipping question 4, so we're going to move to the next page to deal with question 5. So question 5 here says match each statement using only what's shown in our congruent, or in our pairs of congruent triangles. So we're going to match A, B, and C with 1, 2, and 3. Description A says the two angles and the included side, so two angles with a side in between, are congruent to two angles and the included side of another triangle. That one looks like number 2 right here to me. This is going to be drawing number 2. Part B says the two triangles, there are 3 pairs of congruent sides. Well, that leaves 1 and 3 for us. So 3 does not have 3 pairs of congruent sides. It has 2 different sides and an angle. And number 1 doesn't have them labeled, but it does have a shared side here So it actually does have 3 pairs of congruent sides. So this is number 1. And then we're just going to double check that part C matches up with number 3. So this says the 2 sides and the included angle. That means the angle is in between the 2 sides. So yes, that's what we have here. We have the 2 sides and the included angle. So this would be number 3. Moving along, we're going to skip number 6. And so number 6 was going to be the last question on that one, meaning we're on to the lesson 7 questions. So we're going to look at number 1 here and answer, what triangle congruence theorem could we use to prove that ADE is congruent to CBE? So let's zoom in here. We want to prove basically these 2 triangles are congruent. Now, if they don't give us a shared side, the other thing that you should look for are vertical angles. And that is actually what we have here. I like to use just the number of arcs that I use to denote an angle. You'll notice that they use an arc with a line through it. So I could just draw this as an arc with 2 lines in it, but I don't like to do that. It's just not my habit. So those are vertical angles, meaning that now I have an angle, another angle, and the side in between that match with an angle, another angle, and the side in between. So this would be angle, side, angle, angle, side, angle, or just ASA. Oh my gosh, that smiley face has one of his eyeballs broken. There we go. For question 2, we have Han writing a proof that triangle BCD is congruent to DAB. His proof is incomplete, and we want to know how he can fix it. So let's read through it and then just kind of mark some things here. So he's given that DC is parallel to AB. So he did actually mark that. DC is parallel to AB. That's that piece there. So he said line AB is parallel to DC and cut by transversal DB. So angles CDB and ABD are alternate interior angles and must be congruent. That is correct. Sometimes it can be a little confusing, but you need to make sure that your angle arc is touching one of the lines that is parallel and the transversal in order to work. So if he had said this one here, that wouldn't work because we don't know about these 2 lines on the side. So he is good in saying those angles, so I will mark down what he said. He said these are CDB and ABD. He's now saying this one is congruent to itself, the line in the middle, because they're the same segment, which is true. Now he's saying A is congruent to C because they're both right angles. Yes, if they're both marked on here as right angles, all right angles are going to be congruent. So like this is good, this is good. A and C are congruent, so that works. Right, those, maybe we'll just highlight them to show that like, yep, we checked it. Those are congruent, so that works. Now he's saying by the angle side angle triangle congruence theorem, BCD is congruent to DAB. And that is not actually what I think we have here. Because we don't have angle side angle. What he is really missing if he wants to use angle side angle is this piece here and this piece here. Because otherwise this is angle, another angle, and a side. So if he's trying to use angle side angle, we need to do something else. So we can say basically, if we know two angles are congruent in a triangle, that means the third angle has to be. So we can say, and that property is because all triangles add up to 180 degrees. So we can say these two angles are congruent to give him the angle side angle he wants, but we're going to say that it is by the triangle sum theorem, or the triangle angle sum theorem. So we can say angle BDA is congruent to angle DBC by triangle angle sum theorem. And this we would want to put right in here. We would put it before the last step, because he actually needs that those are congruent in order to then say that he has angle side angle. So that's how he can fix his proof. Then we are going to move to question 3 here, which says segment GE is an angle bisector of both these two labeled angles. So HEF, that's this top angle here, and FGH, which is the bottom angle here. What could you use to prove it is congruent, and how do you know it will work? Well, if they told me it's an angle bisector, I know that this angle is congruent to this one, and I know that this angle is going to be congruent to this one. I also know, because I have a shared side here, that EG is going to be congruent to EG. So I could use angle side angle, because I have an angle and an angle with a side in between. So we could use angle side angle. And that would be, how do you know that will work? So we would say EG is congruent to EG. And then I would also say that angle HEG is congruent to angle FEG. And that HGE is congruent to FGE. Nope, that's an E. FGE. These are both, by definition of angle bisector, so just writing down that we actually have those. This is because it is the same segment. And that would give us our two angles with our sides sandwiched in between. Okay, so I think, yeah, we have questions 4, 5, 6, and 7. So like I said, kind of a long assignment, but we're going to try to get through these a little quickly, but with still a decent amount of explanation. We have ACD and BCD being isosceles. So kind of just like our last question on the previous homework assignment, the big one here and the little one in between. BAC has a measure of 33. So again, they're giving us our top angle, 33. And they're giving us that BDC, this bottom angle, has a measure of 35. So we want to find ABD, which again is the interior angle right here. So we have some choices. We can actually use the 33 if we want, but I'm a fan of doing this the other direction, but we can, I'll show this one the other way. So If we use that 33, we also know this is going to be 33 right across from it. Those combined together, this entire angle will be 66. So for the big triangle ADC, 180 minus 66 is going to give us what the other two angles should share. So 180 minus 66 is 114 degrees. Now we're going to divide that by 2, and that'll actually give me what like all of angle D should make. So I can find just a little part. So if I take that, divide by 2, that gives me 57. So D should be 57, but I just need part, so we're going to do 57 minus the 35. That would give me that this little piece here is 22. And now I can just use the idea that an entire triangle adds up to 180 with x degrees, 22 degrees, and 33. So for my last piece, I can say 180, I can subtract 22, and I can subtract 33. And that would give me 125. So I can say measure of angle ABD equals 125 degrees. And I showed my work. It was a little messy because I didn't define any variables, so I didn't have like a full equation to solve here, but I showed it all on my triangles, so it works out because I was supposed to show all of my work. But I wanted to show a different method than I showed earlier in the lesson on the previous homework question. So number 5 says, which of these conjectures are possible to prove? And so we'll just start with what we know. This is saying first, all triangles with at least one side length of 5 are congruent. Well, I need to know 3 pieces of information about a triangle in order to prove it's congruent. And that only tells me 1 piece of information. So I would not be able to prove that. This is not going to work. All pentagons with at least one side length of 5 are congruent. I think with something that has more sides, I would probably need more pieces of information. So the same would go with rectangles. I don't know what the other side lengths are going to be. If I know one side is 5, well, yeah, the side opposite would be 5, but it could have longer sides or shorter sides for the other pair. D is the only thing that's going to work, and that is because squares have 4 congruent sides. So if one side is 5, they are all 5. So that's the only one we would actually be able to prove. For question 6, we have Andre drawing a triangle that's congruent to this one. He begins by constructing an angle congruent to LKJ. So I'm going to mark that one here. LKJ is this angle in the top corner. What is the least amount of additional information he needs to construct a triangle that's congruent to this one? So I might say, in this case, we can do side angle side. I might say he needs LK and JK. So LK, we can say here, length of LK and JK. Now you could also choose angle side angle and use any of the other angles. I just choose to use side angle side here because that's a congruent statement that involves that angle. So answers will vary on that one. You don't have to use my specific answer. And question 7, which I think is our last one. Yep. This is a diagram of a straight edge and compass construction where C is the center of one circle and B is the center of the other. We want to know which segment has the same length as segment CA. So CA is right here. That is the radius of this circle. And that's the bell. I'm filming this at lunch, but we're right almost done. CA, that's going to be the same length as either CB or CD, because all 3 of those are radii. So I actually see CB here as one of my answers. So that is going to be our answer, is option C, because it is a radius. So also a radius. And that's why. So thank you for sticking with me all the way to the end of this video. If you looked at the other lengths, BA, BD, and AD, they would all not quite be the radius of that circle. So this was 2 assignments for one night. So Unit 2, Lesson 6, and Unit 2, Lesson 7 of Illustrative Math Geometry.